Hello, I'm Colby Primer, and I'm the Challenge Communication Commander on Team PACZ. And today we're going to be talking about a new neonatal intensive care unit, also known as the NICU, for premature infants. And this unit will help with heating, temperature, comfort, and safety of these premature infants to help give them a higher quality of life and a higher survival rate while in their premature stage.
For our final concept, we decided to combine all our ideas into one. So we made this unit right here with the mobile wheels that lock, so it's mobile. And this right here, this little spot right here represents the cabinet that's going to go underneath, that's going to hold all the wiring. There are walls on the top so the baby is secure, and all the wiring is everything is going underneath on the cabinet, like I said before, and the feeding tube attachments can go up the side.
Okay, so there are going to be a few tasks that have to be done during the execute step. And the first task that is going to have to get done is shop for all the items in the CETA building next week. And that will be done by a couple of our team members, and they will use our proposed budget to buy the necessary items needed. The next task is to use the $10 to buy a few needed items, including wood and spray paint for our prototype. Then another step in the execute is that we need to 3D print an item, and that item we will be 3D printing is our feeding tube holder. Next, all these items will have to be assembled and ultimately build the main part of this prototype. And then after that, the circuits will have to be put together, and those will have to be tested to make sure that all the codes work through the Arduino to the Mega 2560. And then next, there will be testing for the heating pad to make sure that the baby's being properly heated, and there'll be testing for the thermistor and the digital display to make sure that the temperature can be monitored properly. And the next test that will have to be done is to make sure that the feeding tubes can be held properly inside of the feeding tube holders. And then after the testing, a final report will have to be made by the team, and a final poster will have to be made explaining all of the testing and everything that has been done throughout this project. And that will all be presented on December 18th, 2018.
Hi, my name is Zach McMenemy. I'm the Challenge Tech Commander here on Team PACZ for the Operation Comfort project for Southern New Hampshire Medical Center. I'm going to tell you about our second product, the Universal Feeding Syringe Carrier. The goal of this product is to provide the Southern New Hampshire Medical Center and ICU staff with a simple and easy mounting solution for the feeding syringes that they commonly use in the NICU. The way this would work is it would consist of two parts. The carrier, which you see in front of you in a CAD model, and not pictured, the mounting solution piece of it, which would consist of a device that attaches firstly to the backbone of the carrier, and then would incorporate a mounting solution such as a suction cup or a clamp or like a clothespin, for example, that would then attach to a surface or an object applicable to that mounting solution. Back to the carrier. The way this works is it's a simple 3D printed device that consists of just 4 magnets. The device hinges or breaks at these points here with magnets on either side, and then would hinge at these 2 points here. So it would fold open. You could insert the syringe. The syringe would then sit like so along the top of the device, with the oval part of the syringe, which you use for your fingers, resting again along the top of the device, and then the bottom part of the syringe would sit flush with the bottom loop. This accomplishes the assigned goal in the project of the team coming up with one of the optional goals. So we decided to go with coming up with a mounting solution for the feeding tube, and this is a quick explanation of what that solution is going to be.